So another concept that comes up a lot in reaction is the concept of a half-life. And really it's just, sort of another way to understand the rate. So the half-life is the time, we denoted by T1/2, at which the concentration is half of the initial concentration. So for a first order rate law with a single reactant, then for a first order rate law with a single reactant, then so for a first order rate law with a single reactant, let's write out what we get. We have the log of concentration of A over the concentration A at time 0. Well, A is 1/2 of A0, so this would be, let's write it as log of 1/2 A0 divided by A0. Well, that's clearly log of 1/2 is equal to minus K. And what's T? T is the half-life, so T 1/2. It's not any time, it's that specific time. And so solving log of 1/2, that ends up being, if you remember the properties of logarithms, minus log 2 is equal to minus K T 1/2. T 1/2, the half-life. And so we solve that T 1/2 is just going to be equal to log 2 over K, which can also be written as approximated as 0.693 over K. The log 2 is the exact value. And so what we see is that the half-life is a constant. It doesn't matter where you are in the reaction. The amount of time it takes for half of whatever it is to disappear is going to be 0.693 divided by K. It's not dependent on time, not dependent on the initial concentration. So at any point, if you want to know how long it's going to be till half of what's remaining is gone, just take the 0.693 over the rate constant. Is this a time? Well, the rate constant for a first order reaction is inverse time. So 1 over inverse time is time. This is indeed a time. All right, so let's look and see what that looks like. So we start out a concentration of 16 units. And after a half time, it disappears to 8. Another half time, it's down to 4. Another half time, it's down to 2. And you see this nice exponential curve there over each of the same period of time, the half-life, half of it disappears, which makes sense. If given a certain amount of time, if there's half as much stuff, then it's going to take twice the time for that same amount to disappear. And yeah, so for first order reactions, we get this very nice behavior of the half-life. So we can go back and forth between the half-life and the reaction rate quite easily.